All right, factoring trinomials when a equals 1. So before we've learned that when you multiply two binomials, like x plus 6 times x minus 5, the product equals this, because x times x is x squared, x times 6 is 6x, x times negative 5 is negative 5x, and 6 times negative 5 is negative 30. Then combining like terms in our box, we get x squared plus 1x minus 30. Now we're going to take this trinomial and we're going to factor it. So we're going to go backwards. So if I gave you the inside of the box, you're going to know all the inside pieces, and your job is going to figure out how to get the outside, and you're going to work backwards, kind of like a puzzle. So x squared, the only way to get that is x times x. Well, x times 6 is 6x, and x times negative 5 is negative 5x. And that's how we go backwards. Then we have factors x plus 6 and x minus 5. Remember that we're going to want to factor out the greatest common factor and make sure that our leading coefficient is always positive. You're not going to see this in today's examples, but it is an important first step. Then we can factor using the box or the reverse distribution. I'm going to show you both methods, but primarily I'm going to be teaching this one, the box. First of all, what are we going to be factoring? We're going to be factoring trinomials, which is 3 terms. It's going to be quadratic trinomials that are in this form, so standard form A, B, and C. A, B, and C just represent numbers. Where a is the coefficient next to the x squared, we call that our leading coefficient. And today we're going to look at trinomials where our leading coefficient is 1, which it's always going to start with just x squared. So in this one, a is 1, b would be negative 8, and c would be 12. We're going to look at factoring trinomials that all look like that today. So first, box method. So again, our a is 1, our b here is negative 4, and our c is negative 21. So we're going to start by making our box, and we're going to fill in the pieces that we know. We know that the first term in our box is always our very first spot here. So our first term is x squared, that goes in our first spot in our box. Our last term is negative 21, that's going to go in our last spot in our box. Now, with the middle term always equals the sum of the two diagonals. So these two boxes have to have a sum of negative 4x. That's what I know right now. Then I'm going to use an x square to help me figure out what goes in these two boxes. And how the x square works is you do the product of a times c, and you want that to add up to what does it add up to get to b. So for example, a is 1 and c is negative 21. So a times c is negative 21, and b is negative 4. So I need to think of numbers that multiply to negative 21, but add up to negative 4. And that's going to be, well, 7 and 3 have a difference of 4. If I wanted to add up to negative 4, the 7 has to be negative. These numbers then go in your box, in the diagonals. It doesn't matter where you put them, just that you put the negative 7x plus 3x equals negative 4x. Now the job is to figure out the outside of the box. Well, the only way to get x squared is going to be x times x. Then if you have an x here, you have to multiply it by negative 7 to get negative 7x. If you have an x here, you have to multiply it by 3 to get 3x. So then we filled out the outside of our box. That's our answers. These are called our factors. X minus 7 times x plus 3. It can be written in either order. You could write it as x plus 3 times x minus 7. Either order works. This is our answer though. Those are our factors. So the other way to look at this is reverse distribution. So we're going to start with our parentheses, and you're going to do the opposite of FOIL. And essentially this is kind of a guess and check method. It's easier when a equals 1 than anything, but you know that first FOIL is first, and you know that these first two have to equal x squared. So the only way to get x squared is x times x. Then you know the last two have to equal negative 21. So if it has to equal negative 21 when you multiply, you know one's going to be positive and one's going to be negative, because a positive times a negative is a negative. If it was positive number here, they either both are negative or both are positive. If it's a positive number, they have to be both positive. So then you have to figure out, well, what are two numbers that multiply to negative 21? And you could try, negative 7 and 3, negative 3 and 7, negative 1 and 21, negative 21 and 1. But essentially, these have to add up when you do the outside inside. They have to add up. You have to get add up to negative 4x. So we know the answer from over here was 3 and negative 7. So then 3 times x is 3x, and x times negative 7 is negative 7x. And these two have to equal that negative 4x up here. So then these are our answers. So these were your options to plug in those two spots. You had 4 options to try and guess and check until you got it. So it's a little bit more guessing and checking, but it works. This is more visual. You can do either method, but I'm going to show you a couple more examples using just the box method. So do this example using the box. So we'll start by drawing the box. And you get your first term, your x squared goes in the first box. Your last term, your 6 goes in the last box. These middle diagonals have to add up to your middle term, your negative 5x. Remember, your a is your leading coefficient, b is your middle, c is your last if it's in standard form. You need to find numbers that multiply to a times c, which is 6, but add up to b, which in this case is negative 5. So how are you going to get numbers that multiply to 6? So 1 and 6, 2 and 3, 6 and 1, 3 and 2, but they have to add up to negative 5. So if you have a multiply to a positive, but add up to a negative, they both have to be negative. So these two, negative 2 and negative 3, multiply to 6, but add up to negative 5. So that's what goes in your box with the x's over here. So negative 2x, negative 3x. Then you figure out the outside of the box. So x times x is x squared. X times negative 2 is negative 2x. X times negative 3 is negative 3x. And then you can check it by making sure that all of these match up. So x minus 2 times the factor x minus 3, that's your answer. These are your two factors. If you multiply this back out, it equals what you started with, this trinomial, which you have to check the work right here to prove that. Do one more example. Make your box. Got your x squared here. And the last term, the 1 goes in the last box. This has to add up to negative 2x. So a times c is 1 times 1 is 1. So multiply to give you positive 1, but they have to add up to negative 2, the b term. So the only way to multiply to 1 is either 1 times 1 or negative 1 times negative 1. So to add up to negative 2 has to be these two. So that's what goes in your box. So then x times x is x squared. X times negative 1 is negative 1x. X times negative 1 is negative 1x. These factors end up being the same thing. They could be written as x minus 1 times x minus 1, or you can write that as x minus 1 squared. Either one is an acceptable answer. So all of these had, our middle term was negative. And so when the middle term was negative here, one factor had to be positive and one had to be negative because the c was negative. Here the c is positive, so both your factors had to be negative to add up to a negative middle. If your n term is positive and it adds up to positive, both your factors will be positive as well. So you can see that this will be x squared, 72 goes here, it has to add up to 17x. So numbers that multiply to give you 72 but add up to 17, that's going to be 8 and 9. So 8x and 9x. So x times x is x squared, x times 8 is 8x, x times 9 is 9x. So if your last term is positive and your middle term is positive, then both your factors have to be positive too. If your last term is negative, but your middle term is negative 2, then one has to be positive. Oops, that wouldn't work. One has to be positive and one has to be negative. So negative 4 and 2 would give you negative 2. All right, remember that you can always check your work by making sure that all your multiplication in your box is correct, and when you multiply it back out, you get this answer. You can do it either method, the FOIL or the box method. If you have questions, let me know. All right, thanks.